Okay, so welcome back once again. We continue our discussion on the signed binary numbers, and today we are going to explore another topic in that. So the topic's name is 2's complement. We will see how we can use 2's complement to represent signed binary integers. So there are two things. First, we want to understand how the positive numbers represented using 2's complement form, and then we'll see how the negative numbers will be represented using 2's complement form. So this is a 8-bit representation of the positive number in binary and in the decimal form. So in the decimal form, this number is 58, as you can see, and in binary, these are the 8 bits. So this is a positive number because MSP is 0, and in 2's complement representation, we see that this is same as the positive number represented in unsigned binary integer form. So it is same as what we have seen before. How about representing negative numbers in 2's complement form? So to do so, what we need to do is first, we represent the number in the positive form. So again, this is an 8-bit binary form of decimal 58. This is a positive number we represent. And now we have to take one's complement of this binary form. So all the bits gets complemented. That becomes one's complement. So 0 becomes 1, 1 becomes 0, and so on and so forth for all the bits. Then you have to add 1 to the least significant bit here, LHB. This is an MSB. When you do that, take a sum of these, will generate the carry and the sum. The sum will be called a result, final result in the 2's complement form, and the carries will be as shown. So let us say this number 1 plus 1, the sum is 0, carry gets generated to be 1, that is added here or put up here. Then 0 plus 1, sum is 1, carry is 0. 1 plus 0, sum is 1, carry is 0. 0 plus 0, sum 0, carry 0. 0 plus 0, sum 0, carry 0. 0 plus 0, sum 0, carry 0. 1 plus 0, sum is 1, carry is 0, and then finally 1 plus 0, sum is 1. Here there is no carry. So finally, this is a number which we say a minus 58 in decimal form. And it is minus that we understand from the most significant bit. Remember, for assigned binary integers, the MSB showing 1 indicate it's a negative number. So this is how we understand how the negative numbers and the positive numbers are represented in 2's complement form. Have a look at another example using 2's complement form. So let's say you are given and it is asked to represent decimal minus 7 in 8-bit binary using 2's complement. So what you do is first show its positive form. So this is a 8-bit binary form of decimal plus 7. That is 000000111. Of course, again, have a look at the MSB, which is 0, indicating it is a positive number in binary form. It is same as you represent unsigned binary integers. Then what you do is take a one's complement of this positive number. So 1 becomes 0 and 0 becomes 1. All bits are complemented. Add 1 then. You add 1 to the least significant bit. That will give you sum and carry. sum will be your number in 2's complement form. And so here you see that 0 and 1 becomes 1, carry is 0, 0 plus 0, sum is 0, carry is 0, and so on and so forth. You go till the MSB. So this is the final form in the 2's complement, and these bits are the carry that got generated. Of course, their all carry bits here are 0, so there is no carry. So this is how then you say the number is -7 in decimal. Again, from the binary form, look at MSB, it is 1, indicating it is a negative binary integer. So with that said, we can perform the subtraction using 2's complement form. This simplifies the hardware in computer architecture to do the both addition and the subtraction using 2's complement form, unlike unsigned and the signed other two forms of the signed binary numbers that we have seen previously. So what you do to do the subtraction using 2's complement form is that you perform the subtraction as a addition, as if you are doing an addition. So do so. So this is an example. Let's say you are given the number 7 in decimal and you have to subtract 5 from it. So decimal 7 minus decimal 5. So to do that subtraction, you can basically say you are doing addition of 7 plus minus 5. So to do so, what you do here in 8-bit form, first show the positive 7 in decimal and the binary as shown. The number again MSP is 0 here, so indicating it is a positive binary integer, signed integer. Then you represent -5 in the 2's complement form. But to do so, you have to first show its positive form. So positive plus 5 is, this is what is shown here. Last three bits are 101. Take a 1's complement of it, where 1 becomes 0, 0 becomes 1. All bits are complemented. Add 1 to the LSB and you get the final sum, which is the 2's complement form. And then add a minus sign. That means MSB is 1 here, so that this number in 8-bit form represents your decimal -5. So once you have 7 and then you have -5, put this -5 right here as shown. So have an addition of 7 plus -5. Then when you do so, you get two forms, carries and the sum. And the sum will be then in the 2's complement form. So you see now, when you have 1 plus 1, sum is 0, carry got generated, you put in here. Then 3 bits are 1, 1, 1. Their sum is 1, carry got generated to be 1. Then 3 bits are 1, 0, 1. Their sum is 0, carry is 1. 3 bits are 0, 1, 1. Sum is 0, carry is 1. Again 3 bits are 0, 1, 1. Sum is 0, carry is 1, and so on and so forth. So here 0, 1, 1, sum is 0, carry is 1. Finally at the MSB, 3 bits are 0, 1, 1, sum is 0, the carry got generated, which is discarded. The final 8-bit form of the binary is 0000010, and this is your positive 2 plus 2 in decimal. So again MSB is 0, indicating it is a positive number. So this is how you see that you can do the subtraction using 2's complement form. So hope you found this model useful. If you did so, share it with others for wider reach and stay tuned for more engaging content like this. Till then, wish you happy learning.